Assalamualaikum and hi everyone. Today we will continue on lecture 3 of C. Learning objective for today are: by the end of this lesson, students should be able to A. Determine the compound interest and compound amount. B. Solve problems involving compound amount, period of time, interest rate, present value, and effective rate. And C. Solve problems involving more than one investment and or more than one nominal rate with different compounding rates. Let's look at the examples for better understanding. Example 1. We have a young man has recently received an inheritance of 200,000 ringgit. He wants to take a portion of his inheritance and invest it for his later years. His goal is accumulated 300,000 ringgit in 15 years. How much of the inheritance should be invested if the money will earn 12% per year compounded semi-annually? How much interest will be earned over the 15 years? So here we have two questions. The first one is we need to find how much of the inheritance should be invested. So this will be our capital letter P, which portrays the amount that the young man need to invest. The first question we need to find our P. The second question we need to find the interest earned over 15 years. So this will be our capital letter I. Let's do the timeline. So here we have 0, 1, 2, 3 and the last one will be 15 years. From the problem statement, we can see that there is a mission, which is he wants to take a portion of his inheritance and invest. This will be the mission. So this will be the value of P, amount of P. This is the mission. And then from the problem statement, we also have the vision. The vision is his goal is accumulated 300,000 in 15 years. So this is the vision of the young man. Okay. And then we also have the condition. This is the condition. The condition is 12% per year compounded semi-annually, which means that in 1 year the rate will work for him twice. So here we can portray on the timeline from 0 to 1 year is J equals to 0.12 and it is compounded semi-annually. So it will be like this, which portrays M equals to 2. And it will be the same as the following years until 15 years. So let's write the information on the timeline. Here we have 0. At 0 we have P, which is some amount of money that we don't know. But we know that our SN here will be equals to 300,000 ringgit. This is his vision in order to get 300,000 ringgit. So we will have our I is equals to J over M. J is 0.12 over M is 2. Our N is 15 times 2 will be equals to 30. The formula for compound amount is S equals to P1 plus I N. So just put all the values inside the formula. 300,000 equals to P1 plus I will be equals to 0.06 to the power of N is 30. Simplify the equation, you will get P equals to 300,000 over 1.06 to the power of 30. and it will become RM 52,233 and 4 cents. So this will be the amount of money that he should invest in order to achieve his goal, which is accumulated 300,000 ringgit in 15 years. This is the first question, and then continue with the second question where we need to find the interest. The formula for interest is I equals to S minus P. Our S is 300,000 ringgit minus P 52,233 and 4 cents. And the interest that we get is RM 247,766 and 96 cents. So this will be the amount that interest the young man get over the 15 years. Let's continue with example 2. Here we have a sum of money is invested at a rate of 7% per year compounded annually. How long will it take for the investment to double? Let's assume a sum of money is P. P is equals to P itself. And then here we have 7%. So this will be our J is 0.07, where we need to convert 7 over 100 in terms of decimal places. So we will get 0.07, and then compounded annually, which portrays our M is equals to 1. How long will it take? So the keyword here is how long, which means that the question wants us to find the value of T. How long will it take for the investment to double? A sum of money is represented by P. So for the investment to double, which means that the sum of money will be double itself. It will going to be S equals to 2P. Why S? Because it is the amount of money after the period. Sum amount of money will be 2P, since the keyword is double. Let's portray on the timeline. So we have timeline such as 0 year, 1 year, 2 year, 3 year, and the last is the one that we need to find, which is T year. Compounded annually, so we have 0 to 1 year, and then M equals to 1, so it will be the same loop as the black one. So M equals to 1 year. Then we will write here is J equals to 0.07. Since we have the word compounded, so this is the question about compound amount or compound interest. Let's write the information. So we have P is equals to P itself, and then we have S is equals to 2P, I is equals to J over M, which is 0.07 over 1, N is equals to T times M. Our T is we don't know. Our M is 1. So N is T. Let's put all the information inside the formula, where the formula is S equals to P 1 plus I, and S is 2P. P is P itself. 1 plus 0.07 to the power of T. Since N is T, T is the one that we need to find. Okay, so just cancel out P, left with 2 equals to 1.07 power of T. So here we have the unknown is at the power, which is T. Therefore, we need to introduce log both sides. Log 2 equals to log 1.07 power of T. Log 2 equals to T we bring to in front of log. It will become like this. And then we will have T equals to log 2 divided by log 1 0.07. So just press your calculator and you will get your T is equals to 10.24 years. So this is your final answer. For the next example, example 3, how long will it take to increase 1,800 to 3,002 ringgit at the rate of 7% per year compounded quarterly? The first word we have how long. That means we need to find our T. Okay? And then will it take to increase 1,800 to 3,002 ringgit, which means that 1,800 will be our P. And then 3,002 ringgit will be our S. More than that, we have the rate of 7% per year. This will be our J. 7%, which is 7 over 100, which is 0.07. That's how we change the rate to decimal. So the next word we have compounded quarterly, which portrays our M is equals to 4. Okay. So let's portrays on the timeline. So this will be our timeline. Again here 0, here is 1 year, 2 year and 3 year, because the question asks us to find how long. So it will be 3 year. Compounded quarterly, which means that the rate will work for us 4 times. Here we have the loop from 0 to 1 year, which portrays J equals to 0.07. And then we have the loop for compounding quarterly. 1, 2, 3, 4. So there are 4 quarters in a year, which portrays M equals to 4. It will be the same for the next year, compounding on the next year. Let's rewrite the information. We have P equals to 1,800, S equals to 3,002 ringgit, I is equals to J over M, 0.07 over 4, N is equals to T times M, which is 40. Okay, our N is equals to 40. Just put all the information inside the formula, where we have the formula S equals to P 1 plus I power of N. 3,002 equals to 1,800. 1 plus 0.07 over 4 to the power of 40. Simplify the equation, you will get 3,002 over 1,800 equals to 1 plus 0.07 over 4 to the power of 40. Again, our unknown is the indices, so we need to introduce log both sides. So we just use log base 10. Here we have log 3,002 over 1,800 equals to log 1 plus 0.07 over 4 to the power of 40. So simplify the equation, we will get such that 40 we bring to the front, it will become log 1 plus 0.07 over 4. Therefore, 40 will be equals to log 3,002 over 1,800 divided by log 1 plus 0.07 over 4. Okay, and then you just press your calculator, you will get your 40 equals to 29.48. So T will be equals to 7.37 years. So to answer the question, How long will it take to increase 1,800 to 3,002? The answer is 7.37 years. So this will be our final answer for this question. Next, let's look at example 4. Let's read the question first. Here we have find the interest rate compounded yearly that will double an investment after 6 years. So here the question asks us to find the interest rate compounded yearly, which means that we need to find the value of J. The word yearly will give us M equals to 1. So this will be our timeline where we have 0, 1, 2, 3 year, 4 year, 5 year, and the last one is 6 year. Since the question states that investment after 6 years. So on the timeline, we are going to have this loop, the green loop, which represents our J, which is 1 year. Since the question states that compounded yearly, therefore, it will give us the value of M is equals to 1. And J is the one that we need to find. More than that, we have the information which is the investment will double after 6 years. If we represent our investment is P, therefore, after 6 years, it will be 2P. Then we can rewrite the information where P is equals to P itself, S is equals to 2P, I is equals to J over M, and it will be I will be equals to J only since our M is equals to 1. And the next one is N will be equals to T times M. So it will become 6 times 1. So N will be equals to 6. The formula that we are going to use is S equals to P 1 plus I to the power of N. So 2P will be equals to P, 1 plus I is J, and our N is 6. To simplify the equation, I will leave it to you. Okay? For the next example, which is example 5, if 60,000 ringgit is to grow to 180,000 ringgit over a 10 years period, at what annual interest rate must be invested? Given that the interest is compounded semi-annually. First of all, since here we have the word compounded, therefore this will be compound amount or compound interest. So we need to use the formula regarding compound amount or compound interest. This is not simple interest. Let's look at the values that we have. Here we have 60,000 is to grow to 180,000. Means that we will get 180,000 at the end of 10 years. So this will be the sum at the end of the term, which means this will be our S equals to 180,000. Therefore, 60,000 is the value of P. P is equals to 60,000. Here we are given 10 years period, which means that our T is equals to 10. The question asks you to find annual interest rate. Must it be invested? So it's asking for the nominal interest rate represented by J. So we need to find the value of J. Given that interest is compounded semi-annually, which means that this will give us M equals to 2. So now let's rewrite the information that we have. Firstly, we have the value of P, which is 60,000. And then the value of S is 180,000. The value of T is 10. So J is the one that we need to find. M is equals to 2. The formula for compound amount is S equals to P1 plus I to the power of N. Let's express our I. Our I is equals to J over M. Means that I will be equals to J is the one that we need to find, and M is equals to 2. Whereas in the formula we have the value of N. So we need to identify the value of N. N is equals to T times M. So it will be equals to T is 10, M is 2. Therefore, the value of N will be 20. Just put all the values inside the formula. So we have 180,000 equals to 60,000. 1 plus J over 2 to the power of N, which is 20. Simplify the equation, we will get 180,000 over 60,000 equals to 1 plus J over 2 to the power of 20. So we will get 3 equals to 1 plus J over 2 to the power of 20. Simplify the equation, we will get 3 to the power of 1 over 20 equals to 1 plus J over 2. Therefore, J over 2 will be equals to 3 to the power of 1 over 20 minus 1. So J will be equals to 2 times 3 to the power of 1 over 20 minus 1. Then just press your calculator and you will get your nominal interest rate is 0.1129. You need to express your rate in terms of percentage. Therefore, your final answer will be J equals to 11.29%. So this is your final answer. Next, let's look at about the effective rate or annual effective rate. What is effective rate? Effective rate or an annual effective rate, in short, is the actual rate that is earned in a year. It can also be defined as the simple interest rate earned in a year. The effective rate is useful when an investor wants to compare investments with different compounding periods, but he or she needs to put them on a common basis. Therefore, here we have the formula for effective rate, which is RE equals to 1 plus I to the power of M minus 1. So we need to use this formula in order to find the effective rate. Let me give you a situation so that you know how useful the effective rate. So the situation is here Ali. He is a wise person. He wants to apply an investment that will give him a better return. So he called a few banks to get the investment plan offers by the bank. For the first bank, which is Bank A, offers him a nominal rate of 6% compounded semi-annually. And then he called another bank, which is Bank B, where Bank B offers him nominal rate of 5% compounded monthly. So here, as you can see, there is a difference of compounding period and plan between these two banks. Then, he wonders which plan offers him a better return, since both banks give different value of nominal rate. For your knowledge, bank only provide the nominal rate for you. Okay? And then, he remembered in KMP, he had learned about effective rate that used to compare investment with different compounding period. So, which means that he need to calculate the effective rate for investment plan offered by Bank A and also offered by Bank B. So, this is why we learn about the effective rate. So, now let's proceed with example 6. The investment is made with a nominal rate of 12% per year compounded quarterly. What is the annual effective interest rate? So here we are given the nominal rate, which is 12%. Therefore, this will be our J is equals to 12%, which means that J is equals to 0.12. And the next one, we have the information compounded quarterly. Therefore, this will be our M is equals to 4. And then the question asks for the annual effective interest rate. So the formula for annual effective interest rate is RE equals to 1 plus I to the power of M minus 1. So the value of I will be equals to J over M, which means that our J is 0.12, our M is 4. So our I will be equals to 0.03. Then just put the values inside the effective formula. So we will have 1 plus 0.03 to the power of M is 4 minus 1. Just press your calculator and you will get your answer 0.1255. You need to express your effective interest rate in terms of percentage because this is rate. So we need to write in terms of percentage and it will become 12.55%. So this will be our final answer. So if you can see here, our nominal rate is J equals to 12%. Meanwhile, for effective interest rate where RE is equals to 12.55%. If you notice, there is just a small difference between the effective rate and nominal rate. So it is rare if there is a large difference between them. It may happen, but it is rare. Example 7. Find the nominal rate compounded semi-annually equivalent to 5% annual effective rate. So here we are given 5% annual effective rate, which means that our RE is equals to 5%. In other words, RE is equals to 0.05. And then the question asks you to find the nominal rate, which means that we need to find the value of J. But they also give you compounded semi-annually, which portrays the value of M is equals to 2. Let's rewrite the formula for effective rate where RE is equals to 1 plus I to the power of M minus 1. Our RE is 0.05. 1 plus I is J over M, our m is 2 to the power of 2 minus 1. Simplify the equation, we will get such that 1.05 equals to 1 plus j over 2 power of 2. So we would have square root 1.05 equals to 1 plus j over 2. Just swap the place, right hand side to the left hand side to the right hand side. 1 plus j over 2 will be equals to 1.05. Simplify the equation, you will get j equals to square root 1.05 minus 1, and everything need to multiply with 2. Just press your calculator and you will get your j is equals to 0.0494. Express your j in terms of percentage, we will get j equals to 4.94%. So this will be our final answer. If you can see here, our nominal interest rate is j equals to 4.94%. Meanwhile, the effective rate RE is equals to 5%. So there is just a small difference between them. Next, let's look at example 8. If an investor has a choice of investing money at 6% compounded semi-annually or 6/8% compounded quarterly, which is a better choice? So here we are going to have choice A, 6%, where our j is equals to 0.06 and our m is equals to 2, since it states that semi-annually. Then here we have another choice, which is choice B, which represented the interest rate of 1/8%. So our j will be equals to 0.06125 and our m will be equals to 4, since it states that quarterly. Therefore, it will give us the interest rate for choice A is 0.06/2 and interest rate for choice B is 0.06125/4. What you have to do is you need to find the effective interest rate for choice A and effective interest rate for choice B. Then you have to compare between those effective interest rate. Which one will give you the better choice? Since this question is about investment, so we need to find the higher effective interest rate. So the higher effective interest rate is the best choice to do. So I will leave it to you to do the rest. Okay? from here, we can see that effective interest rate for A is less than effective interest rate for B, because we have 6.09% is less than 6.27%. So as a conclusion, we would write such as, therefore, choice B is a better choice because it has a better effective interest rate. So this will be our final answer for this example. You need to do this comment in order to express your choice. Okay? Here is a quick summary about investment and also loan. If you can see here, if we compare between investment and loan, if you are offered higher interest rate for investment, it will be a good choice for you because you will get more money. But if you get higher interest rate for loan, it will be a bad choice for you because you need to pay more to the bank. And then in terms of smaller interest rate for investment, it will be a bad choice for you to accept smaller interest rate because you will get less money. However, for loan, if you are offered smaller interest rate, then it will be a good choice for you because you need to pay less. For examples, here we have the effective interest rate for investment. If you get effective interest rate for choice A is greater than effective interest rate for choice B, means that A will give you a better choice than B. You need to remember, if you want to compare between two investment with different compounding period, we need to use effective rate. That's why here we are using the effective interest rate. For loan, if you calculate the effective interest rate, and then you will get such that effective interest rate for A is greater than effective interest rate for B, means that you need to choose B because B is better choice than A because the effective interest rate for B is smaller than A. So smaller interest rate for loan will be a good choice because you need to pay less. So roughly, this is the differences between the effective interest rate in investment and effective interest rate in loan.